Okay, today we are going to be solving matrix equations using the inverse method. At first, a lot of people really struggle with this, but we're going to try to get a good foundation down to kind of help us out. So we'll see what happens. Okay, so if you're looking at this, we have a matrix, this guy, being multiplied, a capital letter usually means a matrix. So a matrix being multiplied by a matrix that produces this little matrix here. Okay. Well, let's say we call this matrix A. So this guy we'll call A. And we're multiplying that by this matrix X. And that's going to give us, we'll call that matrix B. Well, one thing that we remember is that we can't divide matrices. That's one of the rules we just can't do. Okay? A little bit later on we'll see why. So in order to get rid of this matrix, because I'm trying to solve for X, I can't divide there, but we do know one key thing with matrices, that any matrix being multiplied by its inverse gives us that identity matrix. And we remember that anything multiplied by the identity matrix just gives us that original matrix. It's kind of like multiplying by 1 in the matrixy world. So if we keep this in mind, we can come back to here. Because again, we can't divide by matrices. So if I were to multiply this by A inverse, A would cancel out. We'd be left with the identity. That's like multiplying by X. X would be by itself. So I'm going to multiply this side by A inverse. Now, a key thing with matrices. Remember, the order matters when we multiply matrices. So if I multiply the left of that side by A inverse, then on this side of the equation, I also have to multiply by the left. I can't multiply by the right, I have to multiply by the left. Well, now, A inverse times A is your identity matrix times matrix X equals A inverse times B. Remember, anything times the identity is just that matrix. So matrix X equals A inverse times B. So what does that mean? Well, I can figure out what this guy is if I take the inverse of this and multiply it by that. So now I just need to find the inverse of that guy. Okay. So A inverse, well, if we remember from the inverses chapter, it's going to be 1 over our determinant. And then with our matrix, we switch those two. So 6, -2. And then you change the sign on the other diagonal. Okay? Well, A inverse. The determinant here, 6 times -2 is -12. -12 minus a -14, don't forget to do that, is going to give us what, a +2. So 1 over 2. Be very careful with the signs. Okay. And now we can distribute that throughout. Now, one thing I suggest to do, usually we like to reduce the signs, reduce the numbers. Just keep them as fractions. You'll see why in a second. Makes life a little bit easier. 6 over 2, 2 over 2. Okay. Now, X is equal to A inverse times B. So X equals A inverse 6 over 2, 2 over 2, -7 over 2. And I multiply that by B. Now, you really had to have multiply matrices down. So if you're struggling with multiply matrices, go watch that video. And then we're left with x equals this row times that column. 6 over 2 times 2 just gives me 6 plus 2 over 2 times 3 is just 3. And then we do row times column. Negative 7 over 2 times 2 is negative 7 plus negative 2 over 2 times 3 gives us what? Negative 6 over 2. So negative 3. I don't know why. It's like drawing a blank for a second. Okay, so x equals 6 plus 3 is 9. Negative 7 plus 3 is negative 10. Notice it's a matrix. So what does that even mean? Great! What that's saying is, if you take this matrix, multiply it by that matrix right there, you will obtain that matrix. Okay? So this is the process. This is the key right here. This thinking is how we're going to solve all these equations, matrix equations, using the inverse method, because we're using the inverse. And this is the key idea right here. Okay? Okay, let's try one more. Okay. Okay. So now this one's a little bit different. Now our unknown matrix is on this side, but that's okay. Let's write this in our generic form again. Let's call this matrix, matrix B. Call it A if you want. It doesn't honestly matter as long as you don't mix them up. Equals, call this guy A, times our matrix Z. Now we're trying to get Z by itself. So I'm going to multiply by the inverse of this matrix here. And remember, you have to multiply them like this in order to get that identity matrix. And since I multiplied on the left over here, I have to multiply on the left over here. So I know A inverse times B gives me that matrix Z. Okay. So let's find A inverse. Okay, well, 1 over the determinant, that's 2 minus 0. So again, it's 1/2. Flip those, negative 1, negative 2. And you flip the sign, well, 0 stays the same. Negative 2. Making that look a little bit nicer. Negative 1/2. 0. Negative 2 over 2. Okay? And again, remember Z is equal to A inverse times B. So Z equals A inverse, negative 1/2, 0, negative 2 over 2, times matrix B, which was over there, 18, negative 12, negative 26 and 1. So you should be able to see in your head, this is A inverse, that was B. Okay, so matrix Z equals, we do our row times our column, negative 1/2 times 18 is negative 9, 0 times 26 is 0. Row times your column, negative 1/2 times negative 12 is 6, 0 times 1 is 0. Row times our column, that's what, negative 18. Then that becomes a positive 26. Remember, we always add the terms when we multiply. but they're two negatives. Yeah, sure. Okay, then this row times that column, that becomes what, 12 plus a -1. Okay. And then making that look nicer, matrix Z equals -9, 6, that's what, 11 down there, and that's what, 6, 7, 8. So what we're saying here is if you take this matrix right here and multiply it by this guy down here that we obtained, whoop, oops, you get this guy right here. Okay? So that's how we do the inverse method. So hopefully let that absorb for a second. This is, again, the key part right there. And don't try to like memorize, well, I do this, this, this. No, no, no. Just try to understand this. Make sure you understand three top things. You can't divide matrices. The order matters the way we multiply matrices. And then any matrix times its inverse gives you that identity. Okay, I lied. We're going to talk about one final thing. Okay. Final one I want to talk about, I promise. Okay. So try to do this one by yourself and see what you get. Welcome back. Okay, so for this one again, let's just go through the steps we did before. Notice though that our unknown matrix is A. So I need to pick different matrices to call. No big deal. So we'll call this guy B is equal to, I'll call this matrix C times A. And we'll make a little note. This is our unknown. Okay. Remember, we want to get A by itself, so we have to multiply by C inverse. Order matters. Multiply on the left, multiply on the right, or left over there. So now we have C inverse times B equals that unknown matrix A. Okay, now when you're trying to find C inverse, 1 over the determinant of C. 6 times 6, we'll even kind of write this out. 6 times -6 minus 9 times -4. Okay? Determinant of C, and that's a -36 minus 9 times -4 is a -36. Well, that comes out to be 0. Ooh. Well, if you think about it, if the determinant's 0, can we divide by 0? No! You can't. So this can't happen. So if the determinant is 0, our answer becomes no unique solution. We're not really sure if there's no solution, multiple solutions. No unique solution just means that there's no one solution, like for the other two, that works for this. Okay, so we can't go any further with what we know. So that's something to definitely keep in mind in your notes. So hopefully this helps. Remember, just take it one step at a time right here. This is the key point. Make sure you understand that. Okay?